So, hello, I'm Leo, so second author there. Thamiris couldn't come because, well, big tech didn't let her come, and so I'm here in her place. So I will be presenting this paper. During the presentation, I'll try to anchor the presentation around the paper so that it's easier for you to read after this presentation, okay? So I'll do an introduction, proxy, I'll talk about proxy tasks, few shot learning, why we're doing it this way, and our case study. So I don't need to motivate this too much, because we're talking about child sexual abuse materials, but I'll just say that the scale has been increasing. So both of these news are saying that in Brazil, we have doubled the reports from 22 to 23, and in the US, 32 million reports have been made. So in Brazil, it is underreported because that's only 71,000. And in the US, we can see the scale of how much CSAM is spreading across the world. We also, oh, okay, yes, I have, second slide, okay. We also have the problem of data being generated for CSAM, as the previous talk has spoken about, and our big tech companies do not handle this very well. So we have news here from Apple not handling it at all, and Blue Sky having a hard time handling CSAM materials, or CSAM, specifically in Portuguese. So the impact of this work is that we want to avoid re-victimization, and we also want to help with the mental health of law enforcement agents that have to go through these materials every day and in large quantities. How we can contribute? We think of this in three ways. So we can contribute, of course, in automated recognition, but not always. We can contribute also doing data triage, and together with law enforcement agents, also doing data analysis. Okay, the biggest challenge that we have is data access and model training. So, as most of you know, we cannot access this kind of data on our labs, and only trained agents are allowed to touch or to see or to keep CSAM data within their labs. So as researchers, our challenge is we have to work with them, and we have to send our models, and that's the only way we can access the data or evaluate on this data. The other problem is, of course, if we don't have access to the data, how are we going to train any models? And this is what the protocol we created is made for. Okay, so what's our plan? The idea is we get data access through partnerships with law enforcement agents, that's Leah's over there, and we do model training using these proxy tasks. And the proxy tasks are always and should always be informed by our talks with these law enforcement agents. Right, so what is a proxy task? So we break down proxy tasks in two parts, and that's not usually done in the literature. Most people focus on subtasks of CSAM or CSI recognition, but we also highlight that there are restrictions within the environments of law enforcement agencies that we have to account for to make these systems actually work in the real world. Okay, so examples of subtasks of CSAM recognition would be scene recognition, nudity recognition, age estimation, and pose detection. And you can see how by combining these tasks that we have public data, we can access data for these tasks, we can have a combined model that would actually work for CSAM or CSI detection. CSI would be imagery instead of material. And the restrictions on CSI, that's what we see from talking with law enforcement agents. Those would be, we have few samples, we have limited hardware, we have distribution shifts, and other general problems with the data like low illumination that would also go into distribution shifts between public data and this sensitive data that we cannot access. Okay, so how do we do this? We created a pipeline for working with this data without accessing it too much, without bothering the law enforcement agents too much, and without asking too much from them in terms of evaluation, because they have their other work to do as well. So we start with data-centric analysis, and that is talking with law enforcement agents and talking between us so that we can propose new proxy tasks and we can propose benchmarks. How do we measure if we're doing this well or not? Then, having a proxy task defined, we follow a common protocol for data science. So we formalize the proxy tasks, we do experiments with the state-of-the-art, we develop new methods, and now we have a model for a single proxy task. What do? We get back to law enforcement agents and we ask them, please evaluate this on the sensitive data so that we can know if this proxy task is relevant, if it serves a purpose, if it works together with the other collections of proxy tasks that you already have implemented. And from that, we would have automated triage models or automated cia recognition models. And we close the cycle because this is an eternal cycle that we go on and on to create more tasks and to solve the problem better each time. Okay, so what is the task that we did for our case study? That would be few shots scene recognition. So we go through all the steps of formalizing these proxy tasks, doing the experiments, developing new methods. I highlight also the partnership with law enforcement agents. In our case, it was with the Federal Police of Brazil, or Polícia Federal do Brasil. So what is few shot? So just very briefly, the idea of few shot learning is that we have very few samples. So we create these episodes, like in a lab, that represents the lack of data. So in this example, we have 3 classes, airport, bakery, and bedroom, and we have 3 examples for each class. We want to classify, create a model using only those samples. And then we do this for multiple episodes to test if our models work with as little data as 3 samples per class. And particularly, we choose a way of doing few-shot learning, that is representation learning or embedding learning. And that helps also minimizing the data interaction between model and data on the sensitive data. So representation learning means that for each episode, we actually learn a representation of this data into a vector space. And we classify using only the distances on that vector space, which means that when we learn to organize the vector space. When we actually evaluate, we only look at the distances from those representations, which means that the model weights never learn from the sensitive data, and we can share that model freely because it never interacted with CSUM at any point in the development. Okay, sounds good? Great. So did it work? Well, we did the whole pipeline. So first step was to test every model that was current at the time for few-shot learning, and we found out that the best one was PMF, pre-training, meta-training, fine-tuning. That's the whole name. And it worked best with a transformer. We also found out that this model works best when it's trained on a larger model, pre-trained on a larger model. So the second table are models pre-trained on ImageNet. And all of this evaluation, all of those choices are made with public data. So public data for indoor scene recognition. Now that we have selected a model, created a model for a few shots indoor scene recognition, we go on to our law enforcement agent partners, and we ask them to test on CSUM data. This is not CSUM data, I forgot about this slide, sorry. This is just the space of our indoor scenes for classes that the model had never seen before. So we can see that the representation space would work for classification as well. Okay, now we have evaluation with CSUM data, and we can see that this model has not seen any CSUM data, yet it can still classify the scenes averagely well. So there is a distribution shift still, and there is a confusion specifically between bathroom, child's room, and living room, but we are going somewhere, and I have to recall that this is only one proxy tasks. And the goal is to combine multiples of them. And the advantage of using representation learning in this way is that we can change the task. So we use the same representation learned from indoor scene classification, and we can classify actual CSI. So here we're classifying between CSI, suspected CSI, drawing other images of people, and pornography. And we can see the common confusion that law enforcement agents tell us that it still happens here. We still confuse CSI with suspected CSI and pornography. But this also shows that learning only from recognizing scenes is somewhat helpful for recognizing also CSI. And we hope that by combining multiple proxy tasks, we can get to a place where we can identify these very well. So this was our case study. This is our team. Do I have 30 seconds to mention everyone? Okay.
Sure.
So I'll say thanks to professors Sandra, Jefersson, Fabrício, me. Our postdoc Carlos is here and will be presenting on Thursday as well. Our PhDs and master students, Thamiris, João, Camila, Andresa, and Gil, and our undergrad researchers, Arthur, Caio, and Clara.
Thank you so much. Big round of applause for Leo.